Yeah, it's Club National, underground, thunder bounce when I stomp the ground. Like a big...
Okay.
Alkenes!
Alkenes!
Damn it, let's do it again. 1, 2. Alkenes!
Okay, so alkenes are basically hydrocarbons that contain at least one double bond, like carbon-to-carbon double bond. So for example, you have something like ethene over here that's very important in hormones of plants. Like for example, we have tomato right here. This is ketchup, but before it was ketchup, it was tomato.
Good stuff.
And ethene was responsible for germinating the seeds as well as ripening the fruit. Fuck it up.
No, you're doing fine. Just keep going. Just keep going.
Okay.
We'll cut it. We're not going to cut any of this.
Okay, so in alkenes there is something called the cis-trans isomerism, which is basically just a different connectivity of atoms. And there... Okay, so in alkenes there is something called the cis-trans isomerism, and basically, fucking Leo, basically an isomerism occurs when a molecule has a different connectivity of atoms. And the cis-trans we have here is when the hydrogens, as you can see, can you hold it up again, Antonia? As you can see, are on the same side of the double bond of the alkene. And then we have the trans isomerism right there. Liam's got it. And the hydrogens are on different sides of the hydrogen bond, as you can see in the pink. And these isomerisms are really important because they play enormous effects in biological molecules, like, you know, insect pheromones.
1, 2. Okay.
Carry on?
We're on again.
Okay, so the next concept we have is polymerization, which involves linking together repeating smaller units like this little marker over here. It can be called a monomer, and you link them together again into repeating units. And you have something called a polymer, something like a base structure. Like in this case for alkenes, they link together, and in the end they form a large structure such as maybe a plastic bag or whatnot in our next example. Or I'm not next example, the following example. My bad. That's it. This trans thing.
Are we recording? Okay.
Yeah.
So one example of alkenes are insect pheromones. Pheromones are chemical hormones that are released into the air or in water, depending on where the animal lives, that are used to communicate between individuals of a species, and pheromones elicit a behavioral response between individuals. Insects use pheromones for a lot of things, one of which is for mating. Females release pheromones to attract males, such as this is a female praying mantis. And she will release, there we go. She will release a pheromone called pentadecanal. Ooh. Let's show them that O. There we go, right there. Yeah, pentadecanal. Oh yeah. Well, that's an alkene that, yeah, she will release it, and it will attract male praying mantids, and they'll come. One remarkable thing about insect pheromones is that they can be used over very great distances. Female moths will release pheromones, and male moths will come from up to 8 miles away, or some god-awful distance. I think 8 miles is accurate enough.
1,000 miles.
No, not 1,000 miles. like 6 or 8 miles, but for a tiny little moth, that's pretty impressive. It will attract males from far and wide to come and mate with them. So yeah, insect pheromones. Oh, and they're often used by humans to, this can be used by humans to attract males for capture if it's a pest species. Unlike her, she's not a pest species. But like moth caterpillar, or like moths or fruit flies or cockroaches, humans can synthesize artificial pheromones to attract the males of the pest species so that they're captured and removed. Cis-trans. Oh, again, back to the cis-trans thing. the isomerism, the stereoisomerism of the pheromone is a very important factor. For example, with male silkworm moths, the trans-cis configuration of the pheromone. Let's see, there's some trans-cis, some trans. Never mind. It's trans, and then there's trans-cis. So the compound has a trans and a cis end. The trans-cis compound is very effective, but the cis-trans form is like 1/10 billionth of the effectiveness of the trans-cis form, and then the trans-trans form is 1/10 trillionth of the effectiveness of that. So the different forms are of different strengths and different usefulnesses. So when they're being synthesized artificially, scientists have to be careful of what isomer they get. And that's the end. The mantis right here. Oh shit! Oh god! Oh no! Oh! Okay, sorry. Ah!
Alright, so another example of alkene use in our everyday lives is the use of plastics and polymers and all that good stuff. Water bottles and bags. So, polymerization of alkenes is an important reaction that always affects our daily lives as consumers. Examples of polymerization.
Keep going!
Polymerization of alkenes is polyethylene, polypropylene, and PVC pipes, which is polyvinyl chloride. And again, you can find it in plastic bags and bottles. So plastics are hard to recycle. There's a grade from 1 to 7, as this bag is. This is a 4, so it's hard to recycle. But nowadays, as we're going green, there's biodegradable products made from like starch.
This is a 2.
So it's still hard,
2.
kind of.
2 right there.
Not as bad,
It's easier, right?
I guess. But yeah, now there's biodegradable bags made from starch that are better for the environment. But,
Okay, 1.
That's better. That's good.
The best. Is the easiest.
Is it really?
1.
Yeah,
Oh,
1.
okay. I wasn't sure about that.
But the polymerization of alkenes, it's not well known to most people, but it's really relevant because it helps us make things that hold other things.
Water bottle.
So
What's a bottle?
That's Gatorade.
there's a big variety of
What's a bottle?
uses
Oh,
with,
Gatorade bottle.
with alkenes and polymerization.
Russel, somebody gonna get a hurt, feel bad.